Okay, so 5.4, we cover the triangle mid-segment theorem. And our objective for this lesson is to use mid-segments of triangles in the coordinate plane and to use them to find distances. So a mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every triangle has 3 mid-segments, and those mid-segments form the mid-segment triangle. So I'm going to trace the mid-segment triangle in yellow to the right here. MN is a mid-segment. It connects the midpoints of AB and AC. MP is a mid-segment. It connects the midpoints of BC and AB. And then NP is a mid-segment. It connects the midpoints of BC and AC. And that forms the mid-segment triangle. So one important thing to notice about the mid-segment triangle is that a mid-segment is parallel to its corresponding side, meaning MP is parallel to AC. Okay? Also, MP is 1/2 the length of AC. Those are the two main properties of a mid-segment. So they connect the midpoints of opposite sides, and they are parallel. Mid-segments are parallel to their corresponding side. So example 1 is a pretty involved example. We have to show the mid-segment is parallel to its corresponding side and that it's half the length of its corresponding side. So we are going to get a quick crash course review from the distance formula. And I'll try and simplify it to make it a little more efficient for us to use. But the first thing, the more familiar thing, is to show that they're parallel. So JL needs to be parallel to MN. To prove that, I've got to find the slope of JL. So the slope of JL, I can just count, or I can use the slope formula. But the slope of JL, I go down 1, 2, right, 1, 2, 3, 4, 5, 6, 7, 8. So down to right 8, which gives JL a slope of -1/4. To prove that MN has the same slope, I simply just count the slope of MN, which has me go down 1, right 4, which should make sense. That should kind of confirm what we sort of already know, is that they should be parallel because they have the same slope. I think that's the easy part. The slightly harder part is to prove that MN is 1/2 of JL, because that requires us to use the distance formula. And to be honest, the distance formula uses something that we're going to cover later on in class, but I'm going to first find the distance of MN, or the length of MN. So using the distance formula, we would do x2 minus x1, and we notice that x2 minus x1 for MN, it's going to end up being 4, okay? Because n has an x value of 0, 0 minus -4 is 4, so I would do 4 squared. The connection I want you to make is that I get that 4 right there. So when I find this distance, I'm getting 4 squared, the horizontal length. If I do y2 minus y1, it would be 2 minus 3, which would be -1, which is what I get from here in the slope. So -1 squared. So 4 squared is 16. 1 squared is 1. 16 plus 1 is 17. So we're going to cover more examples of this. I promise you that. We will cover more examples where we get this kind of down. But to sort of connect finding distance to the slope really does help us do the distance formula a lot quicker and maybe cut down on some mistakes. So if I follow that same pattern before, x2 minus x1 is really 8 for JL, and then y2 minus y1 is -2. So I'm just using the rise and the run for the slope because our slope formula is y2 minus y1 over x2 minus x1. And we have x2 minus x1, y2 minus y1 in our distance formula. So they are connected. So this becomes 8 squared is 64, 2 squared is 4, so that's the square root of 68. So to confirm MN is half of JL, I would do the square root of 16 divided by the square root of 68, We should notice that we get 0.5. So we just proved it's half the length. So for this guided practice, I do want you to try to prove this. We are going to not do number 2 because I feel like we're going to do enough practice with this later. If you want to try number 2, go right ahead, but I'm not going to show the answer on this video. If you want to confirm your answer with me, you can ask me later. But I just want to focus on example 1. So I'd like you to try example 1, work through it, and then when you're ready, check your answers to confirm, you found the right distance, you found the right slope. So take a minute to pause the video, work through it independently, resume the video when you're ready to check your answer. Okay, so really quick, finding the distance using the slope, I use, and this is the confusing part sometimes, but I'm finding an actual length. So when I find x2 minus x1, y2 minus y1 kind of in my head, I'm using the slope for DE, I'm using the unsimplified slope for AC. Because if I use 3 and 2 again, I'm going to get the same length. And we know, obviously, that AC is longer, than DE. So that's why I use 4 and 6 for that slope. So we will get practice with this, but this video is more for what we're going to cover Friday in class. Okay?